Hi guys, this is part 2 of the force in motion. This is called, how does force impact motion? Or, do you like to move it? That's one of my favorites. Alright, so let's see how force impacts an object's motion. Remember that force is a push or a pull. And remember that an object is in motion if the distance between that object and a reference point is changing. So let's take a look at how forces impact an object's motion. That's where we talk about something called net force, which is basically the total force or the total push or pull exerted on an object. Well, you know from video 1 that we have balanced forces and we have unbalanced forces. So here you have two examples. You have a box. If balanced forces are acting on that box, you'll see by using arrows, and I tried to draw arrows about the same size. One arrow is one force pushing to the right, the other one is pushing to the left, and you'll notice that each one has a 5N underneath. N stands for newtons. That's your unit of measure, so we don't have the naked numbers. To find the net force, you take each of the forces on either side of the object. So 5 newtons minus 5 newtons, and we all know that 5 minus 5 gives us 0. So when we have a net force of 0, that means that we have balanced forces acting on an object. Well, what does that mean for its motion? That means that the object's motion does not change. So if an object is still, it's going to stay still or stay at rest. Just like the containers in the middle of your table. If they are still there tomorrow, it's because balanced forces are acting on them. If the object is in motion, then that means the object's going to continue to be in motion. The Earth is a perfect example of this. But what happens if we have unbalanced forces that are acting? Well, you're going to see unbalanced forces with two different sizes of arrows. You see that we have 2 newtons going to the right and 10 newtons going to the left. So you subtract your newtons. 10 newtons minus 2 newtons gives us a net force of 8 newtons. Because 8 newtons is greater than 0, the object is being impacted by unbalanced forces. So that means the object's motion is going to change. In this particular example, this object would then move towards the left because that's in the direction of the greater force. Well, phew, I'm tired. I don't know about you guys, but that seems like a whole lot of work. And I sure am glad that I said work, because what is work? Well, it's not your usual definition. Physics, which is what we're doing, force, motion, and energy, has a definition. Work is done on an object when the force is applied that moves an object over a distance in the direction of the force. Well, what does that mean? Work simply equals the force that's applied times the distance that the object moves, and the object must move in the direction of the force. So here is my picture for you. Pushing a shopping cart, pushing it 20 newtons. The push moves towards the right. The object has wheels, so we've decreased the amount of friction. It's able to move, and it moves over 15 meters. So 20 newtons times 15 meters equals 300 joules of work because the cart is moving in the direction of the force or to the right. Now, if this cart wasn't going anywhere, but I was still applying 20 newtons of force, then I would say by this definition, I was not doing work. You guys do work every day. When you pick your notebook and your books up to leave my classroom, you have done work. But as you're carrying the books down the hallway, you are not doing work because the force that's being applied to your books over the distance is not matching up. The motion that's happening is not matching up. So take some time to look at the examples when you get to that activity where you're sorting work versus no work. And remember that it always has to move in the direction of the force. And if there's no motion in the direction of the force, then no work has been done. All right, ladies and gentlemen, that's a wrap.